In this lesson, we'll go over ESP8266 Development Board and the Breadboard in detail. ESP8266 Development Board is a Wi-Fi system on chip that works with Node MCU firmware. Node MCU is an open-source firmware that lets you directly program on ESP8266 Wi-Fi SoC, or hardware. We will go over hardware ESP8266 on this lesson and the firmware Node MCU on the next lesson. We have mentioned ESP8266 Catalyst some times already in this course, but what exactly is it? ESP8266 is a Wi-Fi system on chip, or SoC, that provides input and output functionality with full internet connectivity in a small package. It is very easy to program with, and because it is a standalone module, it does not require help from a single-board computer like Raspberry Pi to take data from any sensors. Compared to other Wi-Fi solutions, ESP is a great option for IoT projects as it is very cheap and can be integrated into advanced projects with ease. There are many versions of ESP8266 Development Board in the market. For our lecture, we will use this ESP8266 Development Board. Shopping lists from the previous lecture can help you find the correct device. For convenience, if you would rather buy from Amazon or AliExpress, just search for ESP8266 Node MCU Lua. You'll need at least 2 to complete this lecture, and its price point is within $1 to $9. ESP8266 is a relatively simple board. It has 30 pins in 2 parallel rows that are compatible to a breadboard. It has a micro USB port for power and programming, a reset button to control the power, a flash button for input or to flash the module, LED to indicate power, charge, and the status of the chip. Keep in mind that its maximum voltage is 3.6, but the recommended voltage is 3.3. This is a diagram of its pins. The terms may look unfamiliar and complicated, but you don't need to worry about it. Just have this diagram printed out or saved and look at it as a reference if needed. First, the VIN pin on the bottom left gives 5 voltage of power. There will be a time where 3.3 to 3.6 voltage might not be enough. We use this in an exceptional case. There are 3 different pins to give 3.3 volt of power. There are 4 pins for ground, labeled G and D, which represents a negative value. There are various GPIO pins. GPIO stands for General Purpose Input-Output, which allows you to control input or output at runtime. We will most commonly use the 3.3V, ground, and GPIO pins. There is an ADC0 pin on the top left, also known as T-out. This pin is used to read analog values from the sensor. Next is UART, abbreviation for Universal Asynchronous Receiver Transmitter. UART is an asynchronous serial protocol. The UART's main purpose is to transmit and receive serial data. Asynchronous transmission allows data to be transmitted without the sender having to send a clock signal to the receiver. UART is available on 5 pins indicated by the yellow box. Here, TX and RX are abbreviations for transmit and receive, respectively. Don't worry even if something is not clear. This will get easier as we proceed further. Next, we will go over the breadboard. A breadboard is a rectangular plastic board with tiny holes that makes inserting electronic components to circuits easy. This way, you will not have to solder circuits when building a prototype. Let's see what the letters and numbers on the breadboard represent. Here, the breadboard is labeled horizontally from A to J, and numbers run vertically. The max number varies depending on the size of the breadboard. The area encompassed by alphabets and numbers is called the component strip. It is used to connect components like sensors and LED. These holes are connected horizontally in a group of 5s. If you use the A1 slot from the yellow box, it is connected to B1, C1, D1, and E1, but not A2, A3, A4, or A5. The other side of the breadboard, F1, G1, H1, I1, and J1 is not connected as well due to this divider. The outer columns have plus and minus sign. These holes are for power. Red line is the positive and the blue line is the negative. Some breadboards have different color codes, so make sure to follow by the plus and minus sign on top. So if we provide negative power here, it'll be available in the entire column. Similarly, if you provide positive here, it will be available for this entire column. In other words, you may use any holes under a positive column with any holes from the negative column. This is all there is to know about the breadboard. In the next lesson, we'll go over how to download custom-built Node MCU firmware and flash it on ESP8266 from Windows. If you have any questions, let us know on the IoT4E Community Board. Thank you.